Hello guys, welcome back to KD Code. In this video, we are going to discuss about another interesting and I can say it's probably most common project for beginners. It is house price prediction. On that note, let's talk a bit about how we are going to predict the price of the house. For that, we need to consider the attributes. Based on the training attributes only, we're going to predict the price of the house, right? So let's see the sample attributes which helps in predicting the house price. So this is the data set I will be using in this project. Okay, here comes the attributes. The first one is area, which is nothing but the square feet of the house. And the second one is BHK, which is nothing but the number of bedrooms, hall and kitchen there in the house, right? And third one is the age. It is the age of the house, like how long it's been there since it got built. And next two variables belongs to the location of the house, right? Finally, the price, which is we are going to predict in this project, right? This is the data set I'm taking here. Now let's deep dive into the implementation of this project. So the first step is to import our dataset. To import our dataset, I'm using pandas. Pandas is a Python library which is mainly used for working with such type of datasets. So I have imported the pandas package here in the first step, and then I have renamed it as PD, right? So in the next step, I have imported the CSV. That means basically I'm reading the CSV file here. I got stored it in the same folder, so I'm reading it. It is housed in the dataset, and I'm printing the first 5 rows of this dataset. If you see here, the area, BHK, age, city, state, price, they all are same. As I have shown you earlier in this dataset, this is the same dataset I'm using in this project, right? So this is the first 5 rows. And then in the next step, I'm printing the info of this dataset. Basically, I want to see the types of the attributes we are using. So here comes the attributes types. So area, it is int, BHK, age, they are also int, but the city, state, price, they are in object types. So there is a requirement now to convert this object to the int type because machine learning model takes only numeric types as input. Let's print the graph for this numeric types like area, BHK, age. Before that, I will be converting the price to numeric because city and state, we can't convert them to the numeric types. We can encode them, but we are just visualizing the data, that is area, BHK, age and price here. So I'm converting the price to the integer values, basically the numeric values here. I'm using two numeric function here in the pandas to convert this object to integer type or float type maybe. So I'm using info to see whether it is changed or not. So if you see here, price numeric, I got new attribute here. Of course, it has the same values as in price, but it has some different data type, that is integer. So we successfully converted object to integer. Now in the next step, I'm using pair plot in the Seaborn library to see the data in the visual way in the plot. So this is the data. Now at the last row, we can see price numeric compared with all other variables. If you see with the area, it is somewhat increasing. If the area is increasing, the price of the house is also increasing, right? It has some linear relationship. And BHK also. If you see here, the more number of BHKs we have, like the bedroom, hall and kitchen, like more number of bedrooms, the price is also increasing, right? And the age, it looks like increasing, but it is somewhat random. But of course, we can use linear model here between this area, BHK, age and the predicted variable, the predicting variable as price numeric, nothing but the price of the house. So in the next step, let's take the x data and y data. The x data, I'm taking it as area, BHK and age as usual, and the y data is nothing but the dependent data that we are going to predict the price of the house. I'm taking it as y data, right? And in the next step, I'm splitting this data into x train and y train, x test and y test. They are nothing but the training and testing data sets, right? I'm using this train test split function from this sklearn again. I'm using 20% of the data as test data, of course. As you've seen before, I have 117 rows totally. The train test split function converted that 117 rows into 93 rows of training dataset and 24 rows of testing dataset, right? So these are nothing but the shapes of the different datasets here. And then I'm using the linear regression afterwards to train this data. It is nothing but a simple linear regression. From the sklearn, I'm importing it and creating the instance and fitting the model. And then I'm calculating the score, that is nothing but the accuracy of this model, and also predicting the test values, that is x test, and I'm printing it here. So the accuracy of this linear regression model is 85%. So not bad, but if we have more than 90, then it will be good, right? So these are the predictions I got, and in the next step, I'm comparing the actual values and the predicted values. If you see here, 13 lakhs and 13,85,147, it is pretty much close, and 8 lakhs with 8 lakhs 49,000, the predicted value, and actual value is 8 lakhs, right? So it is of 85% accuracy, so we got like this. But if it is more than 90%, then or 95, then it will be very good model, right? So let's go on and try to optimize this model again. So if you remember, I used x data as age, BHK, and if you see here, I have used age, BHK and area as the training data. But we also have the city and state values, but they are of object types, nothing but the string types. Actually, they are of strings like the city name and state name. Now we have to convert that string values or object values to the integer values, but we can't convert them to directly integer values. So what can we do is we can encode the values. So I'm using this label encoder in sklearn again to encode all these city and state values here. So after encoding, if you see the city encoded, state encoded, we got two more variables or columns. So what this label encoder does is it will assign a numeric value to each of the city value and also the state value. So for city Mumbai, it has assigned a value of 35, and for Pune it is 42. So like that, for each unique value it will assign a numeric value, and for Maharashtra it is 8. So if you see, the first three rows have state as Maharashtra, so the first three encoded values is nothing but 888, like that. So it encoded and assigned a unique value, numeric value to each of the unique city and state. Okay. Then I'm using the city encoded and state encoded also in the training data. In the next step, I have encoded this city and state and then concatenated with our X data. Then afterwards, I'm using the train test split again to convert that data into training and testing data sets. Then I'm using the same linear regression model and fitting the model here again. So let's see the accuracy for this model. So I'm printing the accuracy for this model and printing the values and also printing them along with the accuracy. So if you see the encoded model accuracy here, it is 88%. So we encoded the city and state variables here and then used the same linear regression model, the simple linear regression model, to predict our output. That is the price. So we got 2% more accuracy than the previous one if we do not include the city or the state. So after including the city and state, that is also in an encoded way, we got 88% accuracy. So let's see the next step. Now I'm comparing the actual values with the predicted values. Now if you see, it is 13 lakhs and 13 lakhs 81,000 and 8 lakhs 12,000. So previously it is 8 lakhs 49,000 like that, but it is more accurate now, right? So within 2% only we got more accuracy. But what if it got a 90 or 95% accuracy? We'll be getting more close values here. So let's go on again. So there is one more method to encode the city and state values in this data set. So previously what I have done is we got assigned a numeric value to each of the unique city and state values, right? But now what we are going to do is we are going to take each unique value in the city and state as separate variables, separate columns, and we will assign them with a value 0 or 1. But for this case, it is false or true. So what it says is the particular row, the first row, the 0th index house, is it present in the city Ahmedabad or not? It says false, right? Like that, we will ask every other city here, like we will fill this every value in the columns like false or true. Okay, so we got totally 80 columns now. So it got drastically increased the data set, and the columns also increased because there are different number of cities and states here. So we got 80 columns here, and in each column we got filled with either false or true, right? But the machine learning model will not take this false or true, right? We have to convert the data types, that is the boolean type data types. If you see here, these are of boolean type data types. So we have to convert these boolean type data types to integer values again. So what is the logical way to convert these boolean types to integer values? If you ask me, it is nothing but if it is false, we can replace it with 0, and if it is true, we can replace it with 1, right? Simply zeros and ones. So I'm using the same thing. So in this line, what I'm doing is I'm using as type int, so I'm converting these boolean values to integer values. So it will automatically convert them to zeros and ones, right? So in the next step, what I'm doing is I'm taking all the values as x data except this price numeric, city encoded, and state encoded, because we have already seen these encoded values as time data and seen the accuracy already, calculated the accuracy already. Now let's see with this second type of encoding method how much accuracy will we get, right? So I have dropped this price numeric, city encoded, state encoded, and taken all the rest of the data as x data, and price numeric goes as y data. And then I'm using this train test split again to split the data into training and testing data sets. We'll get the same number of shape, we'll get the same shape here again, because I'm using the 2% data as test data set, and I'm using a linear regression model again here, training it, fitting the model, calculated the accuracy again. So it is 85%. It didn't increase, yeah, but it is lesser than the other encoded values. But if I want to compare with some other model like Bayesian Ridge, I'm using this Bayesian Ridge model again from sklearn. I'm fitting the model and predicting the output and calculating the accuracy again here. If you see, it is of 90% accurate. I've tested with the other encoded method 1 encoded values, but it is very less. It is still 82% and 85%. If you have any doubts, you can test it out again. You can download this same IPPNB file from our GitHub and you can test it out. So now with second encoding method, we got 90% accuracy for this Bayesian Ridge model, right? Now I'm checking with random forest regressor again with the second method encoded values only, because I'm getting the highest accuracy if I use the second method only. So I'm using it, a random forest regressor again, predicting the output and calculating the accuracy. So it is of 88% accurate, the random forest regressor. And then I'm using this XGBooster regressor to predict the output. I'm using n estimators as 500 and learning rate 0.5. You see there are many attributes here. You can play with it and fit the model, then predict it and calculate the score, try to increase the accuracy, right? For this I got 89% accurate values. And then for now the highest one is the Bayesian ridge, right? The next one is just the ridge model from sklearn. Again I got, if you see, 91% accurate values than this Bayesian ridge. So if I use the normal ridge model here, I got 91% accurate values than the Bayesian ridge values, right? And then I'm using this lasso model here from sklearn. Again I'm calculating the score, reading the values. If you see it here, it is 93% accurate. So out of this all, I got lasso as highest accuracy, that is 93% accurate, right? 93.04, right? Remember this value. And then next I'm using elastic net model. I'm using the same process, creating the instance, fitting it, predicting and calculating the accuracy again. If you see, it has 86% accuracy. So this is pretty much less. And then I'm using this polynomial features model. I'm fitting it with a degree 1. This is important, guys. The values which you are giving inside these parameters, it is important. The accuracy might change based on these hyperparameters also. So I'm fitting the model, then and I'm using the same thing to transform the X data and using this linear regression, the same thing like polynomial regression. And I'm fitting the model and predicting and calculating the accuracy. It is of 93% accuracy. So it is 93.14, which is higher than our lasso model, right? And then I'm comparing the actual values with the predicted values here, because it is the highest accurate model I got until now, this point. So if you see, for 13 lakhs it is 13 lakhs 44,000, for 8 lakhs it is 8 lakhs 82,000, and for 11 lakhs it is 10 lakhs 85,000, and for 15 lakhs it is 13 lakhs 32,000, and 5 lakhs 96,000. Like that, it is showing me the values, and you can play with it, play with all the hyperparameters, change them and fit the model, train it and calculate the accuracy. Comment down below the video. So after testing, what is the best model, what is the highest accuracy you got while testing it? Okay. So at last I'm using this SVM again with the degree 1 and kernel linear. As we discussed, they had the linear relationship, and I'm fitting it, predicting and calculating the score again. It is 82%. So after analyzing all these models, so I can say the polynomial features and the lasso got the highest accuracy, that is 93%. So if you want to play with this notebook, go to our GitHub and download it and try to explore this data and try to use new datasets, of course with the same attributes, and try to create more models. Then you will get expertise on this machine learning analysis. So for the today, this is the video, these are the models I created. These is for beginners, and if you want to explore more machine learning projects, go to our channel and please feel free to watch them and comment down your doubts. Please subscribe so you will not miss out any of our videos. Thank you, thanks for watching.